So in that last video showing the ratio of fractions and division as a ratio, they seem to do something really strange. And I've heard other students kind of mention this before, that they're going to multiply instead of divide. And that seems very strange. And I kind of think I saw that in that last video. Why we're being asked to divide, but they're doing multiplication. Um, that seems very strange. It doesn't seem to make sense. And I think what they were doing is they were multiplying by this fraction, but they just flipped this fraction around. So I'm just kind of curious. So let's just take a look at that. And does it actually work? So it really shouldn't, because they were doing the exact opposite of what we're being asked to do. We're saying divide, but they multiplied. It should give us a completely wrong answer. But let's try it. And it looks like they did like 1/6. Instead of divide, they timesed. Okay, they multiplied. And they did something over here like this. And they're claiming that this gives us the right answer. So we have 3/12. Okay, so top times top, bottom times bottom. This gets 3/12. Well, that doesn't look, well, oh, wait a minute. That, I guess if we reduce this, oh, look, it seems to work here. Let's take a look at some other example. Maybe that just happened to work here. Maybe let's try this one here. So here we have 1/3 divided by 1/6. So divide by 1/6. So instead of divide, they did the opposite. Okay, and we do the opposite, we're not going to get the same as divide. But they did this. It is times 1/6. So top times top, bottom times bottom. 6/3. Well, that's not. Oh, wait a minute. That does look like that simplifies to 2. That seems to work. So maybe we just got lucky these 2 times. So let's just try one more here. Let's maybe go down to these ones are a little bit harder, I think. So maybe we can try one of these. So 1/8 divided by 1/2. So we go 1/8. And we're going to defy what they're saying there is divide. And we're going to do the exact opposite. And we shouldn't get the right answer if we do the opposite of what they're actually telling us to do. But we're going to do something different. We're going to flip that around. And we get 2/8. Oh, yeah, that does seem to work. So this, I mean, maybe we're just getting lucky, but it seems like we've done this a bunch of times now, and it seems to be working every time. So there must be something to this. So let's try one more here. So let's go 1/4. And we're going to do the exact opposite what they're telling us to do. Instead of dividing, we're going to do the exact opposite, which is times. And then we're going to flip this around. We're going to do the opposite of what we actually have here. And we're going to do 3 times 1, 4 times 1. And it seems to be giving us the right answer. So it seems to work. Okay, so we should really figure out, well, why does this work? Because really, we are doing the exact opposite of what they're telling us to do. Instead of doing divide, we are actually doing time. So why does this actually work? So let's maybe look at some basic ideas and some basic truths in math. For division, we know that top is multiply, bottom is divide. Okay, so anything that's multiplication should go in the numerator. Everything that's divide should go in the denominator. And really, this is just one big fraction because it's all connected by times. It just means that we have our times on top, times 4 times 5, and the divides on bottom. Divide 5, divide 2. We're going to combine our divides. We're going to combine our times. Okay, that's perfectly fine. That's multiplication. So let's see what's really going on here. Here we have 4 divided by 5. Okay, so 4 is times, 5 is divide, so that's on the bottom. That's okay, nothing wrong with that. So let's read the rest of this. This says divide by 2. Well, if it says divide by 2, that 2 really should go on the bottom, right? It should go on the bottom of the fraction. Okay, so that says divide by 2 goes on the bottom. So that makes sense to put it down here. What does this 5 say? It says divide, and I have another divide here. So divide by 5. Well, divide is opposite, opposite. If I do the opposite, opposite, I'm really doing multiplication. So that 5 should really go in the numerator. So it seems to work because we are actually putting the times and divides in the right spot. So when we did this method here, we were just flipping this fraction because this fraction really is showing divide on top, times on bottom. So we just put them in the right places and did it as multiplication. So this is why it works. We're actually putting the times on top and the divide on the bottom. So this is really times, so it goes on top. Divide, so it goes on the bottom. And 4 times 5 is 20. These 5s, or you can cancel those 5s out. This is a correct answer, right? We have 4/5 compared to, and remember, a picture never lies, 4/5 compared to 2/5. Well, that's going to be 4 parts to 2 parts. Yeah, that confirms that that's the correct answer. So this is working. One way we can justify this working is we're actually just putting the times on top and divide on bottom. Another way we can actually think of it as working is if we change this to times, that's the opposite. Okay? And if we flip this fraction, we're just doing the opposite, making divide times times divide. We're doing opposite, opposite. So opposite, opposite goes back to the right thing. So opposite, this is an opposite, opposite. Okay, this is a big idea in math. This idea of opposite, opposite gets us back to the original. The original in this case is times. Okay, so this is divide, divide gets us back to times. So this is actually a very important and useful mathematical idea. It's a very simple mathematical idea of opposite, opposite, but it is an important idea because that idea is very mathematical and it's true mathematically. Okay, so we're gonna we have all these models for division. So we have our, our area model, we have our ratio model, but really we should start thinking of this as times on top, divide on bottom. And if we do that, we can start using this rule. So instead of dividing, divide is a little bit more complicated. So we can actually convert it to a simpler multiplication by doing this rule. So we change the divide to multiply and we do the reciprocal. So this is basically, we're doing an opposite, opposite, which is okay, that we're doing the right thing if we do the opposite, opposite. So we'll try this here. We can see very clearly in the picture, and again, remember the picture never lies. This answer should be 2 parts compared to 3 parts. Let's try our opposite, opposite. We're going to do 1/3. We're going to multiply, so we're going to do the opposite of divide. We're going to do times, but as long as we balance that opposite with another opposite, we get the right answer. Okay, so this answer is definitely 2/3. The picture does not lie. That's 2 parts to 3 parts. Okay, that seems to work. So this idea here of opposite, opposite is the central to why we can use this multiply by reciprocal. Now that we've established that there's a good reason why this multiply by reciprocal works, we can maybe use this as our primary strategy. It's very important to understand the other strategies and the other models because you're going to have to be able to draw them and show them and explain them. But as long as you can explain and understand why this multiply by the reciprocal works, have some justification for it, maybe this should be our primary strategy from here going forward.